Hello, good day to all my Form 5 students. Today we are here to continue on the last part of our thermochemistry lesson video, which is part 6. In this part 6 of thermochemistry lesson video, I am going to concentrate on fuel value and also application of exothermic and endothermic reaction in our daily life. Now, let's go to comparing heat of combustion for various fuels. We have various type of fuels which are used in our everyday life. But what happens is we must know which fuel gives better value. So, I want students to understand that when a molecular formula of a carbon compound increases, technically the number of carbon and hydrogen atoms per molecule increases. Since students have studied chapter 2 carbon compounds, I hope students can understand and relate what teacher telling here. Now, when the number of carbon and hydrogen atoms per molecule increases, the heat of combustion also increases. So that is what I have written here. So why heat of combustion increases when the amount of carbon and hydrogen atom increases? This is because we will produce more carbon dioxide and water molecules. So more heat will be released in order to form carbon dioxide and water molecules. So that is the reason why heat of combustion increases when number of carbon atoms. Here teacher compare with alcohols, methanol, ethanol, propanol, butanol, C1, 2, 3, 4, 5 and so forth. Now, students can see that the heat of combustion for alcohol increases when number of carbon atom increases. So, this shows that more carbon dioxide water molecule is produced. When more carbon dioxide water molecule has to be produced, more heat has to be released. So this is easy for students to understand. Alright, now let's go to fuel value. Now, when we were calculating heat of combustion in our previous video, we were using heat of reaction divided with mole. Okay, so please remember, we as chemistry students and I as a chemistry teacher, we know what is the meaning of mole. But common people, they don't know what is the meaning of mole. So in order to find the fuel value, which produces more heat, okay, which produces more heat, which value fuel produces more heat, we always use gram because gram, the term gram, the unit gram is known by everyone. So fuel value is heat of combustion in kilojoule per mole divided with the molar mass. Why? Because not everyone know the term of mole, but everyone know the term of kilojoule and gram. So fuel value shows that when the molar mass increases, the fuel value also increases. Same, which is when the fuel heat of combustion increases, heat of combustion increases, molar mass also increases for that particular molecule. So fuel value, when a fuel value of a certain fuel is higher, this shows that this fuel is more beneficial. Okay, so beneficial produces more carbon dioxide and hydrogen water molecule and releases more heat. Okay, so this is how we calculate fuel value. So when the molar mass increases, the fuel value also increases. Why? Because molar mass is technically related to this concept. Okay, when molar mass increases, automatically amount of carbon and hydrogen also increases. So more carbon dioxide and water will be produce. So, and the unit that will be used for this fuel value will be kilojoule per gram, not kilojoule per mole, because not everyone knows the term mole. Okay, but many of us know, can identify the unit gram. Okay, so the term mole is not usable. So for common people, we use the fuel value. Okay, in kilojoule per gram. Now, when the fuel value is higher, we say that this fuel is a better fuel. Okay, we say this fuel is a better fuel, but we must also see sometimes fuel value might be higher, but we must also see whether this value is beneficial. Okay, beneficial in the sense of, does it damage environment? Is it abundant? Can we get this value fuel easily? Okay, so these are the few things that we as human beings, as the consumers, we have to consider. Even though a certain alcohol or a fuel gives a better fuel value. All right. Now let's start on application of exothermic and endothermic in our everyday life. All right. Okay. Now, more mainly, teacher would like to highlight on hot packs and cold packs. So hot packs, like what student understand. So the concept of hot packs is we need an exothermic. Okay, we need an exothermic reaction where a certain substance is supposed to produce heat to the surrounding. So here we use anhydrous calcium chloride. So anhydrous calcium chloride is a substance when dissolved in water will produce a certain amount of heat. Okay, so calcium chloride when dissolved in water will produce certain amount of heat. Here is negative 83 kilojoule, not too high, not too less. So that is the reason why for cold packs, hot packs, not all the substance can be used, because sometimes they produce too much of heat. Okay, it's dangerous for human skin. Now, example of other hot packs or substance which can be used as hot packs is anhydrous magnesium sulfate, anhydrous copper 2 sulfate. Teacher repeat, calcium chloride anhydrous, magnesium sulfate anhydrous, and anhydrous copper 2 sulfate. Now, what is the use of these hot packs? Hot packs, they keep us warm, especially when we are in colder areas. Okay, mountain climbing and all that. Okay, so colder areas increases the blood flow thanks to the substance producing heat energy. So when you put it on your skin, you feel that that particular uh, area becomes warm. So blood flow will be increased, and the best is it can help to reduce muscle pain and joint pain. Okay, so muscle pain and joint pain. Why? Because the heat, the warmth from the hot packs will help the blood flow. Now, let's go to cold packs. So, how have I mentioned? Hot packs, we need exothermic reaction. Same goes for cold packs. Of course, I need endothermic. Okay, so we need endothermic reaction where heat energy is supposed to be absorbed from the surrounding. Okay, so the example of cold packs is ammonium nitrate, which is dissolved in water, will produce ammonium ion and nitrate ion. Now, it produces the heat 26. That means it absorbs this much of heat, which is 26 kilojoule per mole of heat energy is absorbed from the surrounding. If you leave it on your body, it will in fact absorb heat from your body. Alright? Okay, so what are the other examples of cold packs? We can use substance like ammonium chloride and also potassium nitrate. So these are substances which can be used, anhydrous. So these are the substances which can be used to produce cold packs. Now, what is the use of cold packs in our everyday life? So cold packs is mainly used to reduce fever. When we have extra unnecessary heat produced by the body because of fever, we want to reduce the heat because too much of heat energy will damage our organs. So we need to reduce the heat energy produced by your body. So we use cold packs. And for cold packs can be used to ease pain from arthritis and sprains. Okay, ankle sprains or any type of sprains. So it will ease pains and also acute joint pains. Okay, acute joint pains also will be not to say healed, but it will be helpful for this kind of problem. Okay, so I hope teacher have explained the meaning of fuel value, how to connect fuel value with heat of combustion, with the number of carbon atoms, and also teacher have explained application of exothermic and endothermic in our daily life. Okay, so teacher have covered thermochemistry chapter for your Form 5 syllabus. I hope students can watch my video few times in order to understand the concepts explained in this chapter. Okay, so till then, thank you for watching teacher's video. See you all. Bye.